How you doing, everybody? Randy Richard in the shop. Today we're going to build the Clawsing 5900 series cross-feed lead screw. Clawsing 5900 cross-feed lead screw. So I'm going to show you the details in Fusion about what we're going to build, and then we'll go over to the lathe and start making the thing, really. So we have a Acme thread here. There's about a 1/2 inch radius on the end. Maybe it's a 1/2 inch, a half round, I should say, 1/4 inch radius on the end here. We can turn around, you can see that. And let's see what else we got here. Other features we have. This is where the gear sits, right here. We have a little pin that locks the other shaft on, and we have a hole here. Now the hole is going to be made to fit the other part of the shaft, and this is not so critical, but we'll make it to the size that is on the old shaft, and then we'll bore a gear to match this. So the other part of the shaft is this little piece right here, and this piece is fine. It's in great shape, so we're just going to reuse it. That way we don't have to remake everything. And then the gear sits right there, and we need to bore this out, trim the length on both ends, actually, because the gear teeth are too long, and the hub is too long. So we'll do that, and we have a little pin right there that holds the gear in place and the two shafts together, actually. So you'll see where that pin, there we go. So you can see where that pin goes right there, or, right here. Here's the gear, new gear, and you can see how the gear teeth are about 1/8 of an inch longer, and the hub, of course, is real long, and the hole is too small. So we'll fix that gear up. Here's that short piece of the shaft that is just fine. The hand wheel goes on this end out here, and that fits in the old shaft, right? And this is the piece. So this is the piece we're going to make, and get that so it's in focus. So yeah, and then the hole in the end, and then we have a brand new nut for it. We picked up on eBay. I could not make it for what whoever made that sold it for, and this is the old one right here, very worn out. It was made of bronze, where this one looks to be made of brass, which will be fine. That's a low speed thing. It has a Gitz, let me drop everything. Has a Gitz oiler in the top, and this part sticks up into the crossfeed, and then you can oil it from the top. And I have a piece of 5/8 pre-hardened 4130 ground rod, so it's nice and straight. It's very consistent in size and all that good stuff. It's nice stuff to use. It makes a great lead screw scratch shaft stuff. So thanks a lot, you guys, and we'll of course catch you in the next one. This is going to be a one-part video, I think. So I also made the 6900, same shaft for a 6900 in a previous video, and I'll somewhere have a card or something like that. So if you want to watch the build on that, this will be very similar. So all right, thanks you guys, and thanks for watching. Let's go to the lathe. So we got our stock in there, and just doing a quick check on the run out for the chuck, and I'm within 1 thou. Stock's in the chuck. First thing we're going to do, since this end has a radius in the end, and we're going to center drill this. We're going to face it, center drill it, so we can support the work while we do the threading. And we're going to leave this part long. I'm going to turn it to diameter that this is, which is, I think it's a half an inch, and we'll turn about an inch down so that we have this turned down and we have room for our threading tool to pass. And then we'll eventually end up cutting that off and then put a radius on the end. This is the pre-hardened chrome moly 4130. I've seen on YouTube several people have had troubles turning it and getting a good finish. The stuff, I suggest not turning it with high-speed steel, but it is doable. You have to really take it easy. Carbide is the best way, but it's about surface feet per minute with this stuff. It likes a lot of surface feet per minute, and it likes to be fed hard. Trying to take 5/1000 cuts, you usually don't get a good finish. It's very difficult. If you're going to use a light cut, make sure you have a really small radius tool. A larger radius tool, I do 50, 60 thousandths all the time, 70 thousandths. And it comes out just perfect finish. So I try to make my finish cuts, in the 15 thousandths range as far as depth of cut goes, and you'll come out with great finishes. I usually turn it around 830, 840 RPM. Now, as the smock gets smaller, like this, sometimes you got to bump up to about 1,000 RPM, and a high rate of feed, 10 thousandths per rev type feed rates, or higher even. I turn a lot of this stuff, and once you find your recipe, if it works, stick with it. Now, getting the end to face off like the cut on your longitudinal is rather hard to do because it's been heat treated. The heat treatment is not necessarily all the way through consistently, so the center is a little weirder, a little softer versus the outer part. So you get a little bit. You can polish it up pretty easy, but you will get a little bit of a surface finish difference. And the other thing with this stuff, you want it, when you're cutting it, you want it to break the chip. You don't want those long stringy chips if you're going to avoid them at all costs. Those chips are very tough. They don't just break. If they catch you, they're going to cut you or they're going to take something with it. So they're really nasty chips. So you don't really want a stringy chip if you can avoid it. That's a 30 thousandth depth of cut. Final cut now. Another 31 thousandths. Well, around a half an inch, and we're 501. 501. That's good. Alright, now we're going to pull it out. Now, I'm only going to pull it out really what I need to pull out. So, because we're doing the threading part first. The most difficult operation on here is the threading. So if I'm going to scrap it, I'd rather scrap it now before I did all the rest of the work. Leave enough room there to work on, and we'll be good. I'm going to make sure I have enough room for my tool, my threading tool. Now, I'm using a carbide insert threading tool that is a 10 pitch acme thread tool. But we need to make sure I have enough clearance. I can come past, that my tailstock's not going to hit the carriage. Lock that in, and we'll be good. We'll be able to come past a little bit, and we'll be able to go all the way down. I was thinking of using a follow rest on here, but this is not that long. I'm going to try it without it. Now, if I get any bowing due to the pressure of the tool, then I'll put the follow rest on. I'm going to put a little thread relief here. The shaft in this area will be 1/2 inch in diameter, so I can go in 62 thousandths and just kind of form a relief for the threading tool. So if you can do acme threads, you should have an acme thread gauge. This is a Starrett one, I do believe. This is Starrett one, number 284. And it has your grind angles if you're going to, of course, grind your own tool. But the notches are the tip width of the tool. This is a number 10, so it's really small. It's the last one on here. That's why I'd rather do it with carbide if I can. This is a pain to grind. But you also can use this to, help set up your squareness to your work. So you hold it on there, and then you can bring it in. Now, being with carbide, be very careful. It's easy to chip the tool. All right, so it's a left-hand thread. We're going to start here, counterclockwise rotation, and feed out. If I feed in, it would produce a right-hand thread, but in this situation, feeding out, it will produce and my cutting edge is up. I checked the machiner's handbook, and for a 10 pitch, the basic height or depth of the thread is 50 thousandths, then plus the allowance, so it's at 60 thousandths is the max, should be the max depth. Now, we're doing this to fit the nut. I don't know what the nut was made to and all that. So we'll cut down in there, and then we'll test the nut, and we'll be going. But we probably won't go past 60 thousandths depth. Touch off there, and then I'm going to zero my dial. There's all sorts of theories, of course, about cutting threads and the compound and all that. Okay. Now, this is a 20. You can set this 29 degrees is the angle of your cutting of your thread here of the tool. So you can set your compound at 14.5, right? I don't do it that way. I've always cut acme threads just by going straight in without using the compound, just using the cross slide. Fine results. It's a very small. This is a small thread. It's a small pitched, small tool, and it's really not a problem. You just don't take as heavy a cuts. That's all. I will use a little bit of oil on there, just a little scratcher for a little bit, and check it. I'm going to turn it down just a couple hundred RPM. Make it a little easy, and we'll probably speed it up. You can use a regular pitch gauge to check that. We're looking for 10, and that's right on the money. 10. Now that, feeling way better. there's zero play in that. It's I mean, I turn it by hand. I think if I just clean the thread up a little bit, make sure all the wire edges are off, and that's probably going to be fine. A little dirt in there, but clean up the edges. I think we're perfect. Just perfect. We ended at 62, which is just right, really. So, yeah, there's little wire edges on there. We'll just run a file through that. I'm just going to run a file through there, little triangle file, just to knock off any wire edges that are on there. I think we're done with the thread. Came out awesome. Just awesome. Now I flipped it around. I'm going to face and center drill this in, so I have support. I put a mark on the threads here, and I intentionally cut a couple extra threads out where the thread needs to end. I just marked the thread point right there, and I'm going to put a little groovy there, and then I'm going to come down here a little bit, 1.667 or so, and cut that down to 1/2 inch. Then we have 5/8, and then we're going to determine the total length, and we're going to cut it off and be good. Alright, I just lined this up, a little bit of Sharpie, and put a little scribe line right there. And we'll just cut that a little on the long side, trim it off, and we're to length, and turn this, bore this, drill a hole, and finish up the other end, and we're good. Alright, I took that down so it's right at 600 exactly in 0/10. Now I need to drill and bore this so this slips in all the way there. It goes in a ways. Where we're at, this is a 408 pin, and it fits just how I want the part to fit in there, right? So it's at 408. 437 is the size we want, so we only have 14 thousandths to take off a side, so it's 28 thousandths or so, 29 thousandths. Now this is a solid carbide boring bar here. It's kind of small, but it is. But it will fit, right? And I can go all the way in with it pretty much. So right about there is my 0 point. Now I'm going to set a dial indicator on the ways and my little digital scale on the ways, so I know where the end is. And now we're going to set this. This tool holder is actually a Bokum boring bar tool holder, and I had to modify it a little bit. I got it from Eric Richards at Turner Tooling,
and I have a lot of Bokum stuff, and it's really kind of slick. You know, it's made to go in a lantern tool post, but I milled it off. I'll show you that. But it's adjustable. It holds 3/8 boring bar, and it's adjustable up and down. It has nice little dovetail ways here, and you can turn this knob and adjust it up and down for height. It's kind of a micro adjust thing, right? It's pretty slick. And then you can lock it on the back side here, and it locks in. Yeah, I took it apart, cleaned it all up, and it works really good. Especially since I have a lot of Bokum stuff, and I have boring bars that fit in here perfect. You know, like these ones, this type here, this is a Bokum one. This is actually a threading one. Measuring small holes are kind of a pain, and they're hard to measure accurately, and I have a set of pins. I'm working on getting a hole set up to 1 inch. I'm up to 7/8, so I think, yeah. So I still got a couple sets to go, but they're sure nice to have and use, especially for small holes. So that's a little on the loose side, but it's 413. 414 doesn't fit. That was 438. You know, 48 and 38 is just not quite gotten to go. That's what went in the other one, but let's see how this fits. Oh boy, that I could probably pound it in. Oh boy, that's a fit. That's like a super optimum fit right there. It fits, but it's nice and snug. Oh yeah. Maybe a little diamond paste, and we'll just lap that in there. Oh, if I take a spring pass, even that is this. I couldn't ask for a better fit. We're just going to leave that. We're going to just leave that alone. Here's the boring bar holder. Like I said, I milled out this notch, and this stuff was heat treated. It was tough. And a BT-1 Bokum boring bar holder. Last thing to do, put a nice little radius in there. Now, radius is go slow. Go slow. I think that looks pretty good. There we go. Nice end to that, and this is just about finished. Fit the gear, drill a hole, and we're done with this. Okay, for the gear. The gear itself is too long, so we're going to face off one of this. And we're going to do that first because I can hold it by the hub. So I need to take off 132 thousandths, and I use my little DRO, the magnetic one here, all the time. This thing is just fantastic, and everyone should build one of these. This thing works so awesome. You don't have to worry about it hitting it. You'll just push back and be a magnetic, and this absolutely works awesome. So I just I'll put the tool up against the touch it against the work, zero it, I can back out, and now I know 137 thousandths. And we'll just go put a little file, knock the corner off on there a little bit. Looks pretty good. Now I'm going to hold it by the gear to do all the boring. Quick measure, and we're 626, 625. That's what we wanted, 625. And I'm just going to hold it by the gear, and then we'll be able to do the boring, and we'll cut the hub down too. Measure the same as the shaft, and oh yeah, there we go. Oh, just nice. That should work. It will go on like this. Oh, perfect fit on there. This was an awesome fit here. Just awesome. Just the air is wanting to push it out. Perfect. And then we just have to now we have to match drill that hole. Oh yeah, that's gonna be fun. Through the gear and the shaft. This is gonna be hard to do. All right, we need to drill the holes through the shaft and through the new gear. Right? They did not drill the hole straight. It looks like they have it on center line, but it's at an angle to the end. It's not a lot, but it's degrees though. It's not just a little bit. Yeah, so using this is very difficult because the hole is really crooked. I mean, it's like this, right? I'm going to drill the hole straight, and the pin will just have to go through. I'm going to use a roll pin, so it should work. Anyway, so this is the old shaft, and I positioned it right over the hole, and on the in and out. So when I tighten this up, it's right there, right? I've got a 3-inch gauge block, and I'm going to position this 3 inches 3 inches in here, so that the end of the shaft is 3 inches from my stop here. And I'm going to mark it with the DRO and lock the table. Now I'm going to put this one in, the new one in, put it up against there, and just lock it in. I can take my gauge block out, and I'm going to drill that hole. Wow, that is well, that's right on the end. Well, that one's right on the end. Yeah, that's the way it is. It's right on the end. You can't get much closer to the end than that. How I'm going to do the gear, I don't know. I haven't figured that out yet. Alright, holes through. Alright, I'm going to put the gear in here 3 inches from the end, just like this one, since the end of the gear is flush with the end of the shaft. So, and I've measured the diameter of this and the difference between the 5/8 where it was holding and that. I had to come over 185 thousandths, so we're going to turn the gear so it grabs on the wide part of the teeth, which it's not right now, and 3 inches over, and I should be in the center, and we're going to drill it. Okay, that feels good. And we're just going to drill that right on through. And okay. Well, sure looks good. So that goes on there, and on both the sides look like they line up. See if we can get all three to line up. Well, I can see through it. Oh, you know, that's probably going to work. If I pound that pin through, I think that's going to work. I'm going to call this done here. Anyway, Scout says, we can call this project done. If you don't watch Scout Crafter, you should. He's a hoot. Anyway, so we're going to call it done. And the most challenging part was probably getting these holes, that cross hole drilled, believe it or not. But it all goes together really well. The gear's going to go on here. They line up like so, and then this fits beautiful inside of here, just beautiful. We're going to put the pin in. It will fit in the package, all put together. So I'm going to put it together. You can see here how the broken gear was very broken, splayed out, cracked, just a mess. This is completely worn out on the inside of here. Now, you know, this would be a challenge, but you could probably do it. Bore this out, insert a new piece, I'd solder it in, and then recut the threads. You probably could do it. It'd be a bit of work, but it's probably doable. There's probably enough meat here to cut that out enough to maybe do that. But I don't know. You know, it'd be tough. Anyway, this is really nice. This new one. It's made of brass, but it's well made, very well made. And you know, this left-hand thread goes on real well. Just zero, almost imperceptible backlash there. Just almost imperceptible. But you got to have a little bit, otherwise it's not going to work, you know. instead of the 30 or so thousandths that this one had. These threads are knife edges, just knife edges. So that's going to work just beautiful there. And I think we're going to put this pin in here. And so the saga continues. So that hole was at about a 10-degree angle through there. And so what I decided to do is I put it in the mill, and I ran an 1/8 inch end mill through there. And of course, you know, because the hole's not straight at all, you know, this end's a little bit bigger. But now things at least line up, right? So what I'm going to do is I'm going to put a taper pin in. And so we're going to get this lined up here. And since everything kind of goes through there right now, and we're gonna put a taper pin in here. So we're gonna ream it with this 0 size taper reamer, and we're gonna fix this up so we can put this together a little bit better than it was, I hope. Over here on the welding table fixture plate, another great use for it, and my strapping clamp idea with the threads, fireball tool blocks, and I've clamped this down and in position and together. I want to make sure I hold it together as I ream this hole here. And I have my taper pin handy to size check. Now this is a really long one. We'll have to cut it off, obviously. Of course, use plenty of oil. You have, when you're doing this, when you're using a taper pin reamer like this, make sure you go slow and easy. Always slow and easy, so you don't overshoot your sizing, especially if you have a shorter pin and stuff. And going through multiple parts is always a little tricky too, so just be patient. Okay, so my reamer now it's starting to come through. And it's cutting. Plenty of oil. I'm through about 3/8 of an inch of the reamer. Let's give that a test. Oh yeah. Now before, the tip of this pin would just get to the other side. Just make it. Now I have about a 1/2 inch sticking out, and I can push it down tight if I wanted to, and such. I'll pull this out. It just wasn't in there too tight. Okay, pull it out and clean out the hole. Put the pin in. I'm going to tap it down tight. I'm going to undo this and make sure everything stayed together. Loosen this side up. And there, it stayed perfectly tight. Okay, so I think we're done there. And we'll take a look at it. There, we have about half the pin sticking out this other side. And it's rock solid, just rock solid. So I'm glad I think this is a good fix for that crooked hole that was in here. It was just so bad. And I think this will be a very solid fix. Very solid. I'll get a better hammer, tap that in a little more before we cut it off. Alright, that's nice and tight now. And I think we look really good. Really, really good.